it's important to be able to graph a linear function. So to graph a linear function, we've gone over all this before, but I'm writing it out in pretty explicit steps. Okay? To graph a linear function in the form ax plus by equals c. Now in a minute we'll get to the form y equals mx plus b, which is an alternative, and there are other alternatives, but these are the main ones. Okay, if the form is ax plus by plus c, it's very easy to find the x and y intercepts. The x-intercept occurs when y equals 0, which removes this term and gives you ax equals c, so x is c divided by a. When for the y-intercept, x is 0, so this term goes away, leaving you by equals c, so that y equals c over b. Okay, so to find the x and y intercepts, okay, we sketch the line through the intercepts. Okay, we get the two intercepts, we plot them on a graph, and we sketch the line. Okay, then we check by finding another coordinate on that line, another point on that line that's not very close to either of the intercepts, estimate its coordinates, and plug into the equation and see how close the two sides end up. So this should work pretty well, unless you have a very large or a very small slope, in which case you go to the alternative, which we'll talk about separately. So, go to just apply the process. Let's say we've got y equals, got myself a little cramp there. Now that looks like 3 raised to the y. We're going to understand that's 4x plus 3y equals 12. Let's write it out coherently. 4x plus 3y equals 12. Okay? X-intercept. Y equals 0. So 4x equals 12. That's, of course, because 3 times 0 is 0, and you just end up with 4x equals 12. So x is 12 divided by 4, which is 3. Dividing both sides by 4, a step that I prefer you not leave out until we're really clear that everybody understands the rules. Okay? So, there we have it, which means on my graph, when y is 0, x is 3. That's the x-intercept. So let's just say here's 3, and there's my point. And we'll go ahead, since we've now declared a scale, to mark off a few more points. So we go up to 5 here. Okay, the y-intercept occurs when x equals 0. So 3y equals 12, and you fill in the blanks, but y is equal to 4. So when x is 0, y is 4, the point 0, 4, the y-intercept would be, let's just put it here. There's 4, so here's 2, 1, 3, got 5 up there. Now we don't have necessarily equal scales on the two axes, although we're not too far off. But that won't make any difference. So we're going to put an x here, that's the y-intercept. And then we sketch a straight line through those points. Okay, well, that's it. We've sketched the line. Very simple. Now let's go ahead and mark off the scale down here. So let's say here's -4, so here would be -2, there's -1, and -3, not marked very accurately. Let's just take a point out here. Okay, let's just take the point where x equals 5, and we're going to project over here. And we're going to conclude that when x equals 5, we get y equals between -2 and -3, I'm going to say about -2.7. I didn't subdivide this interval very well, so it might be much closer to 2.8. And, there are other little anomalies that could occur, but that's going to occur anytime you do a graph that you're hand sketching. So that's not going to hurt anything. Okay. We want to be able to take the coordinates of this point, which are now 5, -2.7. I'll put a little question mark there. Is that point on the graph of this equation? Okay, the linear equation that represents this, or the implicitly defined linear function, whatever you want to call it. Okay, in other words, do these coordinates satisfy this equation? Okay, so check. Is 4 times 0.5 plus 3 times -2.7 equal 12? Well, it's going to be 15. Sorry, 4 times 5 is 20. Got a number in my head and didn't look at the number I had. That wasn't going to work out. I was going to get a number in single digits, which is why I took another look. And then that's 8.1. And we get 11.9 equals 12. And that's pretty good. And this should work out well, unless you've got a very steep graph, which would make it difficult to accurately locate, let's say it's steep this way, to accurately locate your x-coordinate on the graph, on a hand sketch graph, or very shallow, which would make it equally difficult to locate your y-coordinate accurately. You tend not to get the right slope if the graph is either very steep or the slope is very close to 0. Okay? So in that case, we go to the alternative. So I'll talk about that in a separate video, because right there is the basic method you want to use, and I'm addressing this in response to the difficulty some people had in sketching the two lines for a pair of simultaneous equations. And the simultaneous equations are often given in this form. Okay? But there are many other uses of this form. It's in many ways simpler than using the slope intercept, although that's simple enough. And we'll see that next.